Hey Professor, today we're going to be talking about mass conservation and the continuity equation in terms of this cock gun. So, what I want to figure out is how to get a constant flow rate of half a cubic centimeter per second coming out of this orifice. I want to figure out how fast I would have to push on this side to get that to happen. So, we start with the mass conservation equation. This means the change in mass over the control volume and the change in mass of the control surface equals the change in mass of the total system. For this, we're going to say that change in mass of the total system stays 0, and we're also going to assume steady state conditions, so that means the change in mass of the control volume is also 0. So our control volume looks like this, and the mass coming in is over here, and the mass out is over on this side. So our equation reduces down to the density times the area in times the velocity in equals the density times area out, velocity out, or flow rate equals V times A as well. So we can put that in as well. For this equation, the density cancels out, which is why they're crossed out here. We can reduce this to figure out what the velocity we'd have to push here to get a constant flow rate of half cubic centimeter per second over here would be. This equation would be velocity in equals the flow rate out, or we can reduce that down to area out times velocity out, over the area in. Since we already know the flow rate out, all we have to figure out is the area in, and we can do that just simply by measuring this. And we get that to be about 5 centimeters, which is 0.00196 cubic meters. So, when we put that in the equation, we figure out that the velocity we have to push on this side to get a flow rate out of a half cubic centimeter per second would be 0.06 millimeters per second. And we can get a rough estimate of that by using this cock gun. Ah, yeah, it works!